Inputs are how we detect things from the real world. So this can be anything from detecting if someone walks into a room, someone's put mail in the mailbox, to sensing a chemical like a smoke detector, or the wetness of a soil from your prized plant. Inputs come in a variety of forms, and usually we use sensors to be able to detect things. So we're going to go through a couple. The simplest one is a button. So basically this is a closing of a circuit. We're going to have a look at pull up versus pull down, as well as an ultrasonic distance sensor. And after you're done, you're going to have the basis of being able to read any particular sensor. Buttons come in a variety of forms, but at their core, they simply close a circuit. We're going to show you how to wire up a button so that it can give you the signal that you need to be able to detect it in the Arduino and then execute some program or some code as a result. This gives you a trigger to be able to run a particular function. So say someone put something in the mailbox, when the mail got pressed in, it would push the button and then you could run something like an indicator or a light to tell you that you've actually got mail. So here we see the Arduino connected to a switch. Let's explain a couple parts here. So this is what's known as a pull-up switch. The reason that it's pull-up is that when you push the button, you receive a high signal. It pulls up through the resistor. So let's step through each part of this. So here we have a small button. This one is referred to as a double pole double throw. In this particular button, these two pins here and here are connected when we push the button, and these ones here and here are connected, but they do not bridge across here. So here we have 5 volts leading into one end of the button, but it's open at the moment. And on the other side, we've got ground connected through a resistor into input number 2. So when we have a look at the Arduino code, we're going to see that the normal state is low, and only when we push the button does the 5 volts come to this point. At that point, we'll be able to see 5 volts here. And so that will give us a high signal. The reason that we have the resistor here is because if we connected the high, the power, and the ground at the same time, we would create something called a short. And that's actually very bad. In terms of a large amount of current would flow from the high to the low and likely short something out along the way. So we have a resistor to resist this amount of current. So when we're wiring it up, we do it in this manner. Here is the schematic view of what we just wired. You can see that between ground and input number 2, we have a resistor. And then between 5 volts and 2, we have the switch. This is the symbol for the switch. You can see when it's pressed, it will close this and allow the flow of electricity into this spot. The reason it can actually work this way and we're not shorting anything out is because 2 is such internally high resistance that it will resist the amount of current coming through. So what will happen is the switch will get closed, 5 volts will appear here, and it won't actually go in with much current because there's a high resistance. It will fall across the resistor and into the ground. And that's how we prevent shorts. Let's jump over to the code to be able to read this sensor. So to be able to read the sensor, we're going to take advantage of some of the examples again. So if you go File, Examples, Digital, Button. And this opens up the button example. So we're using our 10K resistor to resist the current going into pin 2, as mentioned before. But let's start stepping through some of the code here. We start by declaring some initial constants. This is int as in whole number, and this is the one that we're plugging into, so input number 2. And we're going to be outputting to pin 13, so that onboard LED. To be able to handle a button, you need to be able to set that it's going to be an input. So that's what this part is doing here. We're reading the button. So we've asked the pin mode of the button to be an input. So that's number 2. Here, we start by reading the state of that pin. So we do something called a digital read. We ask it which pin to be reading, and it stores that state in button state. So that's because it's a digital, is either going to be 0 for off or 1 for on. Now we use something called an if. An if basically says, if it is true, do this. If it is false, do something else. So the structure of if is start with the word if. We put the first state in brackets. And in this case, we're asking the question, is the button state equivalent to high? This is a little bit different than a single equals. This means compare. The other one means assign. So up here, it goes, this variable, put 0 into it. Assign 0 into this. This one here means compare the two. Take button state and tell me if it's high or low. If it's high, do the next part of code. So the next part of code is whatever is in these brackets here, these curly brackets. So we've asked it to say digital write to the LED, turn the LED high. So if the button's high, make the LED high. And then we have something called an else. So an else always follows an if. If we just had it just like this only, then it would exit and then continue. But we're going to have another state for when we don't get this. So the opposite of this state. And we use else. If this is not true, else we do what's here. And what are we doing here? It's another digital write to the LED and turning it low. So you can see what this is doing. If the button is pushed, if the button is high, so there's voltage detected at it, then it will turn the LED on, otherwise turn the LED off. So let's have a look at that. So we've got the circuit wired up like the diagram shown before. We've got power going into one side of the switch, and that's open at the moment. So that's a normally open switch, NO. Sometimes you get normally closed, NC, meaning that the switch is closed until you push the button, then it disconnects. On the other side of the switch, we've got the resistor separating between ground and signal number 2. And so what it does, having the resistor between here and here, is it keeps signal number 2 low. The reason you want that is sometimes you get stray electromagnetic fields and you might get a false positive. So the resistor keeps it low like that. When you push the button, you're going to be seeing 5 volts here, and then it drops across the resistor because this resistor is less than the internal resistance, and that way you don't fry it. So basically if you wire it up in this way, you'll always be safe. So let's try it out. It works. Here are a couple other types of switches. These all have the same concept behind them. When you push the button or when you release the button, contacts are bridged across. So this works in this one. So this one connects the center pin to the external 2. So when it's in this state, it connects these side, and when it's in this state, it connects that side. This is similar again, but it's got 2 sets of contacts. So when it's in this particular state, it connects this one to this one, and this one to this one, separated, and then the opposite as well. The center to this one, and the center to that one, keeping separation down the center.